Okay, so let's have a look at example 13. Example 13 says use technology to solve for the following system of simultaneous equations. So we've got here x minus y plus z equals 6, 2x plus z equals 4, and 3x plus 2y minus z equals 6. So we have three unknowns, x, y, z, which implies that we have a 3 by 3 matrix for the matrix of coefficients. So let's set up our matrices. So let A equal the 3 by 3 matrix of coefficients. So the first row is 1 because it's 1x, negative 1 because it's minus 1y, and plus 1 because it's 1z. Next line, we have 2x, so 2 here. We have no y, so 0 in that coefficient entry, and we have 1z. And then last line, we have 3, 2, and negative 1 for the z. Our x, our unknown, is always our variable column vector, column matrix of variables, x, y, z. And then lastly, B is the column matrix of the whatever the equation is equal to, that single number there. So 6, 4, 6. B is equal to column matrix 6, 4, 6, a 3 by 1. So because of matrix equations, we have A times X equals B, because row by column equals entry, row by column equals entry. You go through the same blurb of how do you get x by itself, because we can't divide by matrices, so we need to multiply both sides by the inverse matrix. So because our A is on the left, we multiply the A inverse from the left hand side. So A inverse A is identity, and identity times anything is that matrix itself, so therefore x is A inverse B. So therefore x is that 3 by 3 matrix inverse times B, that 3 by 1 column matrix. Now, because this is a 3 by 3, we can't solve this algebraically yet until unit 3. So for now, we'll have to rely on our graphics calculator. So make sure you state using graphics calculator, because that tells the reader how you got your answer. So I'm going to jump over to my graphics calculator, turn it on. So right now, it's not to the back default 4 tabs, so I keep pressing exit until I get back my 4 tabs, my default tabs. F3 for matrix vector. I'm going to edit the 3 by 3 one. So 1, negative 1, 1, 2, 0, 1, 3, 2, negative 1 is matrix A. I also need a matrix B, a 3 by 1 matrix of the coefficients. So that was 6, 4, 6. So 6, 4, 6, exit, exit. I need to work out the inverse of A. So OPTN, F2, mat. I need match A inverse, so shift open bracket there. So if I press enter, I get a lot of thirds. So I have 2 thirds, negative 1 third, 1 third, negative 5 thirds, 4 thirds, negative 1 third, negative 4 thirds, 5 thirds, and negative 2 thirds. So you write that down as your A inverse, and then we need to multiply that by matrix B. So I would go mat of the answer times mat of B, and then you get 14 over 3, negative 20 over 3, and negative 16 over 3. So you finish off with your sentence conclusion. Therefore x is 14 over 3, y is negative 20 over 3, and z is negative 16 over 3. Obviously, the easiest way to check your answer is to substitute back into your original equations. Your left-hand side should equate or be the same as your right-hand side values. So make sure that when you're trying to solve matrix equations, if it's 2 by 2 matrices, we expect you to solve it algebraically and show working algebraically. But if it's higher dimensions, 3 by 3 or higher, we haven't learned the algebraic techniques yet, so just rely on a graphics calculator, making sure your reader knows that you are using a graphics calculator. And let's do part B. So part B again, we have x, y, z, so 3 unknowns. I'm expecting a 3 by 3 matrix. So again, let's set up our matrices. Let A equal, so capital A for matrix. So coefficients 1, 2, and 3 for 1x, 2y, and 3z. Then next line of coefficients is x minus 1, minus 3, and positive 2. So remember, when you're setting out these coefficients, your x's are on the same stacked column, your y's on the same stacked column, and your z's on the same stacked column. And then lastly, you have negative 1, negative 4, and 7. X is your column matrix of your unknowns because you're trying to solve for x. B is your coefficient, the this constant values on the end, so 13, 2, and 17. Again, set up your matrix. So A, X equals B, because row by column equals that first entry, row by column equals entry, row by column equals entry. Give me the blurb about how you solve for X. So multiply both sides by A inverse from the left, because it's A on the left of X. Ix equals A inverse B, so X equals A inverse B. So that tells us that X is substituted in your A, that 3 by 3 matrix inverse times that. And then again, let's use a graphics calculator. So exit out all of that. Nope, wrong one. F3 to enter your matrices. So my 3 by 3 is 1, delete. 1, 2, 3, -1, -3, 2, -1, -4, and 7. Exit, and then my B matrix, my column matrix is 13, 2, and 17. Okay, so if we exit out of that, we want to work out A inverse, so OPTN, F2 for mat, F1 for mat, matrix A, we want inverse, so shift open right bracket. It gives us a mass error, right? So that tells us that that inverse doesn't even exist. And that's okay, right? Because we explained before, even if a 2 by 2, that not every matrix has an inverse, right? Because if the determinant is 0, then you can't have inverse, because you can't go 1 divided by 0. You get a math error. So in this case, this 3 by 3 matrix for A gives us a math error when trying to find the inverse, so it doesn't exist. So we just write using graphics calculator X equals, there's a math error. So what that means is there are no solutions. So therefore there are no solutions to the set of simultaneous equations. And even if you try to solve these equations using substitution or elimination, you won't be able to solve for any solutions.